Hey everyone, welcome back to the channel. Today we're going to see how the Apple Silicon transition impacts the old Intel-based Macs after 5 years. Are they still worth buying? For you that still use one of these, is it time to buy a new Mac with the M series chip? In this video, I'm going to show you everything and we're going to compare some models to see how much have changed in the last years for Apple. Apple announced in 2020 that they were breaking up with Intel. It wasn't a surprise. Performance gains were slowing, power efficiency was falling behind, and Apple wanted to have full control over their ecosystem. Over the last 5 years, M1, M2, M3 and the M4 families of chips were introduced. This wasn't just a chip change. It was a reimagining of what a computer could be when hardware and software were designed together. By building chips in-house, Apple unlocked new levels of integration. They could align macOS, their apps, and the hardware around a shared architecture, streamlining everything from boot speed to battery life. With ARM-based design, Apple moved away from the historical PC architecture. This leap allowed for dramatic improvements in thermals, performance per watt, and even battery longevity. Let's talk about raw performance. For this, I'm going to compare some of the most powerful chips released for the Intel Macs. The Core i9-9980HK, used in the 2019 MacBook Pro, Core i9-10910 from the iMac and the Xeon W3275M from the Mac Pro with some models of M-series chips. First, let's see the total performance for them. Using Geekbench 6 numbers, we can see that even the most powerful CPU available in the Intel times can't beat the current base model in multi-core, and when we compare the single-core performance, the M4 is more than twice as fast as the Xeon or the i9s. When we take a look at the energy consumption of these chips, the Xeon goes straight to the top, and one interesting thing is that the M4 Pro consumes almost the same as the mobile i9 but has 3 times the multi-core performance. This is the key thing about the Apple Silicon. The efficiency that Apple got with their custom-designed chips would never be achievable using Intel or any x86-based processor. Another thing is that thermal throttling on Intel was common. Under any long intensive task, the clock speed of CPU would go down by 30% or even more, while with Apple Silicon, this doesn't happen even in the MacBook Airs without fans. Apple Silicon wins by far any test of battery life. The 16-inch Intel MacBook Pro lasted around 9 hours in real-world usage. The M4 MacBook Air, up to 20 hours video playback and 14+ hours mixed productivity. And it's not just about longevity. The MacBook Air M4 does it without a fan, runs cooler, peaking at 38 degrees Celsius during heavy load, while the Intel model can hit 90 degrees Celsius and trigger fans to full blast. In graphics, the last generations of Apple Silicon have evolved dramatically. Even if the first 2 generations of Apple's own chips were not so powerful in GPU, after the M3 family they turned the game, competing with some dedicated graphics cards in lots of scenarios. When we compare the Geekbench 6 GPU results of the RX 5600M, the most powerful GPU for the last MacBook Pro, and the RX 6900 XT, that was never sold with any model of Mac, but it's the most powerful graphics card compatible with the 2019 Mac Pro, we can see that the performance of Apple's custom chips is something really interesting to see. The base model M4 is tied with the RX 5600M, while the RX 6900 XT stays between the M4 Max and the M3 Ultra. But we have to remember that the M4 performance can be found on MacBook Airs without fans, and when we compare the TDP of these chips, we can see that the AMD ones require a lot more energy than the M series to get these numbers. AI acceleration is also Apple's strength. The M4's 16-core neural engine delivers 38 trillion operations per second. In tasks like real-time transcription, background removal, and ML image classification, Apple Silicon completes operations up to 5 times faster than Intel Macs relying on CPU-only inference. Universal apps mean native performance across both architectures, but Apple Silicon pulls ahead. Adobe Premiere exports are up to 35% faster on M4 versus Intel i9 in side-by-side tests. Logic Pro handles up to 1.8 times more simultaneous tracks. Rosetta 2 enables most Intel apps, but native Apple Silicon apps unlock full efficiency, lower memory usage, faster load times. Apple Silicon is the king of efficiency. And this, everyone already knows. This is so true that all models of MacBook Air released after the Apple Silicon transition come with no cooling fan and still hold the same level of performance as other models that come with the fan. This allowed Apple to design their new computers with completely different visions of that time from the Intel machines. One great example is the M4 Mac Mini, which is way smaller than the previous generation and is one of the best value computers you can buy right now. Apple Silicon integrates the Secure Enclave, speeding up biometric security, hardware encryption, and even secure boot operations. File vault decryption during boot is now 2 times faster. And because it's built into the silicon, there's no need for firmware patches or additional chips to stay secure. Compared to Intel Macs, this is a major step forward in both speed and reliability when it comes to security. Apple Silicon Macs instantly pair with AirPods, support continuity camera with zero lag, and can airdrop large files in seconds. It's a seamless experience. Shared memory architecture helps, too. Final Cut can share RAM between CPU and GPU, speeding up timeline scrubbing and 3D rendering. No need to copy data across chips. It's not just faster, it's smarter. The entire ecosystem now works as a single unit. There are still use cases for Intel Macs. Boot Camp, for one, if you need native Windows 10 support. Apple Silicon can't do that. If you need to use dedicated graphics cards, this is also exclusive to the older models, since Apple Silicon-based Macs don't have the drivers to make external GPUs work. Parallels on M4 runs ARM Windows shockingly well, but if you rely on legacy drivers or software, Intel might still make sense. So, should you upgrade? If you're on Intel and don't rely on niche software or Windows booting, yes, absolutely. Even the base M2 MacBook Air scores over 8,500 in Cinebench are 23 multi-core, better than the top-tier Intel i9. Are Intel Macs completely dead? Not entirely. Some workflows and hardware dependencies still demand them, but for most users, they're outdated. Used Apple Silicon Macs are a huge value now. On eBay, M1 MacBook Airs are under $600, and base M2 MacBook Pros dip below $1,000. With 5+ years of updates and better performance, it's an affordable jump for anyone. Apple Silicon has transformed the Mac. Better battery, more power, tighter integration, and with the M4, it's only getting better. If you've made the leap, let me know what your experience has been. And if you're holding out, what's stopping you? Thanks for watching. Hit like, subscribe, and ring the bell for more in-depth tech breakdowns every week. See you in the next one.